So Prith Banerjee, you have been CTO at Ansys for 5.5 years. You are driving product innovation that in turn drives product innovation to our customers. Right. You even wrote a book called Innovation Factory. So my question is, what are the major trends at the moment that will further drive innovation at our customers?
Absolutely. So we have customers in sort of 5 different verticals. We have customers in the automotive area, in aerospace and defense, in energy, in high-tech semiconductor, and in the healthcare area. And our customers are always sort of building products. And in the past, before use of simulation, they used to imagine a product. They start with a requirement and they come up with a conceptual design. They design a product. And in the past, they used to build a hardware prototype of a product and test it. And they say, well, I don't like it. So they do it again. And they don't like it, then they do it again. And the cost of hardware prototype-based innovation is very high in terms of the financial cost and the time cost and so on, right? Which is where sort of simulation comes in. And so what we help our customers is with the use of simulation, we go down to the detailed physics level, either whether it's structural physics or fluids physics or electromagnetics physics. And we are so accurate that if we say this plane is going to fly, this plane will fly. If we say this car is going to crash, it will crash, right? So we are so confident of that capability. And that's sort of the use of simulation, right? We allow our customers to try out different designs, right? All in the virtual world without the need for any physical prototyping. And what that allows them to do is to get their products out much faster, much cheaper, and with less risk, right? So improving the quality of the design. That's what makes our customers successful. And what makes us successful is the future sort of technologies that we are putting into our products to drive all the innovation.
And exactly on which technology are you working at the moment? Can you disclose a bit of this future, how it will look like for us? So
today in the CADFEM conference, I kind of gave a talk on the future of simulation-driven product innovation. And so we have about 50 different products across 10 business units. And we have products in the area of sort of structural products, fluids products, electromagnetics products, and so on. What I am driving as CTO at Ansys is sort of 5 technology pillars on which there is a lot of future stuff, right? So the 5 pillars are: 1, advanced numerics, right? So in the core of Ansys, we take physics equations and we solve it with numerical methods, right? So be it, if it is fluids problems, it is sort of Navier-Stokes equations and we solve it through finite volume methods. Or if it is electromagnetics, it is Maxwell's equations we solve through finite element methods. So in the core of the numerical methods, we are looking at advanced geometry, meshing techniques, multi-physics interactions, multi-scale methods like ICME. I talked about high-order methods, like going from second order to third order. Talked about mesh fusion technologies, which is allowing us to do very, very large problems for non-conformal technologies. And so there's a lot of innovations happening in the advanced numerics area. The second area that I talked about was high-performance computing, right? Our solvers take oftentimes 1,000 hours to run, 10,000 hours to run, right? And so we would like to make these solvers run much faster. So in a given amount of time, our customers can do a lot more design iterations. And I kind of talked about the different technologies using shared memory, multiprocessors, message passing, using MPI, GPU. We talked about a lot of GPU-based technologies. And then in the future, we are working on things like quantum computing and AI-based hardware and so on. The third area is around AI, machine learning, using AI, ML to drive much faster solvers as well as easier to use technologies. So we kind of talked about technology around SimAI to run things much faster, Ansys GPT to kind of make our customers' lives easier in terms of the use of our tools. Fourth pillar is that about cloud and platforms. We have a lot of our customers are taking our solvers and running them on the cloud like AWS or Azure. And we have a SaaS-based cloud platform that we're working on. And then we are taking all our solvers, providing Python interfaces to the solvers, and then allowing our customers to build entire sort of apps or workflows to run our solvers in the backend. And the final fifth pillar is around digital engineering, which is the whole concept of model-based systems engineering, where we can take a system-level requirement in languages like SysML and then use it to drive collaboration across multiple teams, where you will take a requirement, and here is the thing that will require a physical product development using mechanical tools or fluids tools, the electronic parts of the products using HFSS or Maxwell or semiconductor tools, and the software part using SCADE, Medini, and tying all of those together with this systems architecture modeling tool. So these are the 5 technologies that I talked about: advanced numerics, HPC, AI, machine learning, cloud, and digital engineering. And it's super, super exciting.
Yeah, that's very exciting. That sounds like a lot. The question that most of our users must have now is how to get started with all that. I mean, if you want to drive digital transformation, if you want to go into the AI world, what would you recommend them to start with, or how?
Yes. So obviously there are different, depending on the customer, right? We'll talk about different things. So, for example, if they're already using simulation and they have a challenge with respect to run times, right? They want to run things much faster so they can do a lot more design. Then they will use our HPC capabilities, right? Running it on shared memory or message passing or GPUs. If they want to get even higher speed ups, right? Super linear speed, then they may try use our AI tools. If they have access to the cloud, they can use our cloud software and so on. But the most important technology with respect to digital transformation is actually our digital engineering area. That is the thing that I am really stressing a lot these days. In the past, different customers used to have different functions. A mechanical engineering group that was only looking into the mechanical parts, right? And then the fluids group working on the fluids part, the electromagnetics group working on electromagnetics. And the way those teams collaborated was by sending emails or Excel sheets and showing. And now in the new world of digital engineering, you come up with this system architecture model, which is this single authoritative source of truth. And that is going to drive all the designs. So my guidance to customers who are embarking on digital transformation is to home in on this digital engineering pillar and see how they can do much faster designs, reduce the design iterations, and do it at much lower cost.
Yeah, this comes together to what we are doing here, the title of this conference, Empowering Digital Engineering. And I like to see that as what you mentioned here. You have digitization, the first level. Then you have digitalization, digital transformation. I always like to compare this to the DVD, DVD rental, and then the streaming platform.
Absolutely.
So we're expanding this, but there is also quite a huge human factor around that, which is something we are working on, of course. But how do you see the synergies now between Ansys and CADFEM in order to bring this to life, actually?
Absolutely. So CADFEM is one of our best partners for the last more than we started the partnership in 1982. So it's been like almost 40 years of our partnership. So we greatly appreciate this, right? So the way the partnership works is Ansys, we develop our products like Ansys Mechanical or Maxwell or HFS. And these are fantastic products, right? That can provide a numerical solution to our customer's problem, right? But these things, if you want them to run really quickly, right, you have to run it very, very fast, right? And there's a trade-off between accuracy and speed, right? You can get it to run much faster if you're willing to let go of the accuracy. And then sometimes you get very accurate, very sort of high speed, but it takes a lot of time to use the right settings. That's where CADFEM comes in, right? With the expertise that your engineers have, right? It makes the power of our tool, right, much, much better with our customers. And we work with CADFEM in improved workflows, right? So think of sort of like almost like apps. I was just talking to a customer who has needs with respect to designing motors or valves and so on, right? So they can obviously use the or Maxwell tool or HFSS within themselves, or they can work with CADFEM, with their engineers, with your engineers, and showing them the potential of working with our products and so on. Now, in this area, there's a role for AI to make it easier, right? So today, our customers can say, hey, write to CADFEM or to our ACE engineers and say, hey, we are trying to do this motor design, valve design, and here is the setting for Maxwell that we have used, and it's not quite working. Then the CADFEM engineers or ACE engineers will reply back saying that, oh, you should use this tool, right, this setting. And so there's a question and there's an answer, question and answer. And what we have done is we have taken the last 20 years of question and answers, put them into Gen AI, the sort of ChatGPT kind of stuff, right? And so we have trained ChatGPT on all those customer interactions. And what we've just announced a product, a solution called Ansys GPT, which is an on-prem solution. There's no issues about customers losing their own intellectual property because it is not sitting on the cloud, it's sitting on-premise at Ansys. What it does is those first order level support, right? Instead of burdening a CADFEM engineer or an Ansys engineer, it is just done by Ansys GPT. But then the second order, third order, the more complicated question, the more exciting things are things that CADFEM will do. And so that is what we are doing today. But in the future, we are working on AI technology to not only respond saying that, oh, you should set Maxwell to these things. It will do the settings automatically, right? Because I kind of mentioned that all as part of our cloud and platforms work, we are taking all our solvers and providing Python interfaces to our solvers. But it turns out the actual Python call, that scripting can be automatically generated with Gen AI. And so we are working on some technologies in that area, which is super exciting. So then the question is, what does the AI do and what does the human do, right?
Exactly.
And it is this, and it is not like the AI will replace the human, the engineers at CADFEM. It will just make the CADFEM engineers like superhuman. They will have so much capabilities, right? So they'll bring to bear all the knowledge because a human designer often forgets because there's a limited amount that you can remember. With Gen AI, it will provide all those things to the CADFEM engineer and the Ansys ACE engineer to bring all that knowledge to the customer. So the customer is happy with the outcome.
Sounds very exciting. Yeah. And yeah, this leaves with the question also for our end customer, our users. Yeah. What should they focus on for the future? Which area of expertise, which skill sets they should focus on?
And that sort of brings to the fact just what I explained with respect to the CADFEM engineers becoming superhuman, right? Our customers would become superhuman in their design skills, right? Because today, the way sort of design products work, right? So you start with a specification of a product, right? Suppose you are building an electric car, an EV car, and today I have a car that has a range of 200 kilometers and a 0 to 60 kilometers in maybe 5 seconds. And in the future, I want to design a car that will have a range of 1,000 kilometers and it'll go from 0 to 60 in 1 second. That's the requirement. Now, in the past, the engineer will have to say, oh, if I have to go from 0 to 60 in 1 second, I need this big motor, right? What kind of size of motor? Do I need a 2 horsepower motor or a 5 horsepower motor or a 100 horsepower motor, right? And obviously, the motor designs, there's all kinds of choices. Should I use a DC motor, AC motor, and so on? So the designer has to think about what component they should choose. And then you say, well, in order to drive that motor, you need a lot of battery power, right? And then you have a range of 1,000 kilometers, right? Well, with a small battery pack, I can go 100 kilometers. If I have to go to 1,000 kilometers, I need 10 times the battery pack. So now the designer has to think, oh, I need this size battery pack and so on. So in their mind, they're doing all those different conceptual designs. Well, with AI technologies, right? Once you start with a requirement, based on prior designs, it can guide the user, the customer saying that, hey, for this requirement, why don't you try a 300 horsepower AC motor and maybe try a 100-cell battery pack, right? So it guides the user in coming to a quicker solution, right? Using generative AI, right? And then it's not like it is replacing the customer. The customer then will finally say, hey, I don't like, so the Gen AI technology will provide the customer with 3 choices, right? And then the customer says, no, I like this, this, and this. Validate through Ansys simulation, right? With all Maxwell and HFS and so on. And then the designer does the most optimal design. In the process, the designer becomes a superhuman designer. Their CEO is super happy. Wow, you did the design of this electric car with a range of 1,000 kilometers in just a matter of 1 week, something that used to take 4 years to do. So it makes you more productive, and that helps your company in growing top line revenue. So it's improving the productivity of the design community.
Yeah. So superhuman.
Superhuman, absolutely.
Super product, superhuman. We're all happy in the end.
Absolutely, everybody's happy.
And you mentioned software as a service briefly. It seems to me that it sounds like a drift of development towards CADFEM, towards users, so that we are empowered also with the ability to empower others, to multiply this effect through a broader audience than of users. Do you think this is already now, or is it safe to assume that we can do this in the near future?
So we have a grand vision from Ansys, right, which our CEO has shared with our investor deck, right? So it is called pervasive insight, and what it is saying is that today the number of engineers who can use Ansys simulation, right, are those analysts. So if you have 100 engineers, only 5% of the engineers in a company can actually use Ansys simulation, because to use HFSS, you have to have a PhD in electrical engineering to know exactly what settings to use from HFSS to get the fastest, more accurate solutions, or a PhD in aerospace engineering to know what settings to use in Fluent, or a PhD in mechanical engineering to know what settings to use in Ansys Mechanical. But this is going to change, because what we are building is we are trying to build a concept of democratizing simulation, right? Where not just 5% of engineers, but all engineers can use simulation, right? So we are essentially dumbifying the use of simulation, right? So we are creating Python interfaces to all our solvers and then allowing our customers to build workflows, right? So suppose you are designing a electric car, that example that I talked about, right? For electric car design, you start with a requirement and you have to run Maxwell to pick which size motor I will do, right? Then you have to use Fluent to design the battery system. Then I have to use a tool for the power electronics part. Then I have to use the electric power train to use Ansys Mechanical, right? You are using different Ansys tools. You connect them up as a workflow using PyAnsys, and these solvers may run on-premise or on the cloud. And then the user just gets to use an app, almost like an app on your iPhone, right? So on your iPhone, here is an app, and you're just ordering a pizza from this thing, right? And it's so easy to use. So we are envisioning a future where the design of products will be so simplified, right? That anybody can use, all engineers can, not just engineers, even non-engineers can use things. For example, we are working on, in the city office, we are working in the area of healthcare. We are imagining in the future a doctor or a nurse just before doing surgery on Prith for his heart surgery, right, will use Ansys simulation, and using these kind of workflows will be able to guide a patient-specific surgery for Prith to replace, to insert a pacemaker inside Prith's heart to take care of arrhythmia. That is a power that is, again, it's a vision of pervasive insight where anybody can use simulation. And we are working on it with the cloud and platform work that we have.
It seems to me that CTO is not the right title for you. You're the Chief Innovation Officer, or the Grandmaster Chief Innovation Officer.
I have the best job in the company. I tell my CEO, I have because I have the luxury of imagining the future and then working with all the R&D engineers at Ansys to kind of take those visions, right? So we have said, this is what we'll do with HPC. And then working with our center of excellence of HPC experts and saying, how will we use GPUs and multi-GPUs to solve? So I have the luxury of imagining the future, but also working with my colleagues to execute the future. It is the most fun job I have. And this is the third CTO job I have. I've had been CTO at Ansys, but before that, CTO at ABB and Schneider. And the CTO's job are the most exciting jobs in the industry.
You're staying longer by Ansys.
That's true.
And you mentioned high power computing and so on. You mentioned also briefly quantum computing. Yes. What about that? What are you doing on this?
So this is actually, when you look at, the technologies that are going to disrupt our industry, right? And so 5-6 years ago when I joined Ansys, when my CEO asked me, what is the technology that will disrupt? I told him it is AI, machine learning, right? And we worked on it for the last 5 years, and we have essentially created some technologies, right? Partly from the CTO office, partly from the BUs, and we have got this amazing set of products which we announced at the conference called SimAI, Ansys SimAI, Ansys GPT, Ansys AI Plus, and so on, right? So, but that technology is now out there. It is in the hand of products, and we are working on it. So then my CEO says, what's the next technology? And what are you going to work on? That is actually quantum, right? Now, it's not going to happen in the next 3 years, but in the next 10, 15 years, I am absolutely sure that quantum computing is going to be a technology that everybody will use. And I will tell you why, right? So I talked about high performance computing, right? If you have a problem that takes 1,000 hours to run or 10,000 hours to run, if you give it a P processors, 100 processors, in the best case, we can take that 1,000 hours and make it run in 10 hours, right? So I get linear speed up. You have P processors, I get P times speed up. Well, with quantum computing, if I have P qubits, right, the speed up will be 2 to the power P, which is like exponential, right? So if I have today, IBM System Q has 433 qubits, or they're having 1,000 qubits, right? They're announcing things with 2,000 qubits, 4,000 qubits by the year 2034, right? So the speed up will be 2 to the power 433, 2 to the power 4,000, which is massive things, right? Something that is taking you 10,000 hours to run will work in a matter of seconds.
No time for coffee anymore.
But the thing is, quantum computing works in certain applications, like in problems that are NP complete, optimization problems like travel and salesman and so on, right? It is not clear yet to us, right, how quantum computing can solve numerical methods simulation, right? The problem of fluids and structures and so on. So it is because our problems we are ultimately solving linear system of equations which may take maybe order n cube time. So it is not obvious how quantum computing will be used to accelerate that. But just like I didn't know how AIML would solve the problems, right? People say, oh, AIML cannot be applied to simulation. We changed that. I am similarly making a bet that quantum computing will change the way simulation will be accelerated in the future. I'm very excited about that.
That sounds great. That sounds amazing. Any last words you want to communicate to our users for the nearest future, maybe?
So again, as I said, quantum is way out there in the future. Yeah. But in the short term, I think digital engineering digital transformation, digital engineering is absolutely around us. So how do you take a problem of a requirement and very quickly go from the requirement to a product using virtual prototyping, virtual design, and so on. So that is the most exciting thing that is going to transform the 5 industries that we serve, the industry of automotive, aerospace, energy, high-tech, and healthcare.
That's great. I'm looking forward to this.
Thank you. Actually, one thing I will tell you that across these 5 industries, right, the industry that has not used simulation enough is healthcare, right? Yeah. Even today, in the healthcare industry, as people come up with new medical devices or a new drug or so on, right? They use the concept of clinical trials, means they will come up with a new device, right? And they will test it on first test it on a monkey. then on a donkey, then on 5 sort of monkeys and donkeys, then on 1 human, then on 5 humans, and so on, right? And it takes a long time to do those clinical trials, right? So, for example, when the COVID vaccine was invented, right, it took 1 month for this mRNA-based vaccine to be developed by Moderna. It took 1 year to get the clinical trials, right? We have a vision that with simulation technologies, we can do what is called in silico trials, right? So we'll simulate 5,000 human patients all on a computer, right? So you don't have to test it on 5,000 actual humans. We will create 5,000 different models of some female, some male, some sort of slim female, some obese males, and so on, all kinds of things, right? Some males with heart disease, some with high blood pressure. So all the kinds of scenarios will create computer models, and then you bring in a new medical device or a new drug, it will be tested through in silico trials. Once that vision is done, it will transform the area of healthcare.
That's bringing the digital twin really to the human.
Absolutely. We are working on digital twins of the human, human body, the human heart. We have got digital twins of the human heart, the human lung, the human brain, and so on, and the human body. And that is going to totally transform the healthcare industry.
I'm looking forward to meeting my twin
yes.
in the future.
Thank you so much. Really appreciate it. Wonderful.